Cool. So welcome to the Pravega community meeting. We have been, not doing community meetings for a little while, but I think that it's a good thing to resume doing them again. So first of all, welcome everybody, and yeah. So let's start with some updates about what has been happening in the Pravega community in the last. In the last months. So recently in September, we were able to attend the KubeConf 23 in September in China. So you can see there the stand of Pravega, and thanks Luis for attending the event. I think that he did a great job disseminating Pravega in Shanghai. That was cool. There is another KubeConf, I think in Europe, in Paris, I think, in a few months. We will try to attend as well. What else? Yeah, so Pravega has been or is a key technology in two European research projects, and that's important. The projects are the NEAR data and the Cloud Skin. They are mostly related to doing processing and data analytics and processing data in the cloud edge continuum. You have the links here if you want to dig a little bit more in what are those projects and what are the different partners. But there are three-year projects which are funded by the European Commission, and Dell is part of it, and we are using Pravega as one of the key technologies, especially for streaming storage. And another interesting item I wanted to share with you is that we got two scientific papers accepted in the middleware 2023. Both are about Pravega. So I think it's an interesting milestone, because thanks to this we are going to reach the scientific community as well, which is a kind of different type of community, but it's an interesting one. So let's hope that we can also get like a further attention with those papers to the project. I'm going to briefly summarize what's new in the latest Pravega release, which is 013. It was released in September. And the highlights are, one of them, which I like a lot, is the new bindings for long-term storage. Basically, now Pravega supports storing data in a Google Cloud platform and also Microsoft Azure. So you can deploy Pravega in those clouds and store data in their storage services. There has been a lot of work in improving the documentation. We are still working on that. There were also many security vulnerabilities that were fixed, stability improvements and bug fixes, and other improvements, especially in the client. For example, now our Python binding for Pravega supports Python 3.11, and there are new APIs for managing streamcats and so on. Have a look if you want to try the latest release. And without further ado, we are going to start with our speakers today. First, we will have Enrico Olivelli, which is from DataStax. He's a committer in the Bookkeeper community, and yeah, he has been helping a lot. He's also a committer in Pravega. He has been helping us a lot, especially in what's related to the interaction between Pravega and Bookkeeper, and he's going to explain us some work that he has been doing regarding Pravega and LangStream.ai. So, Enrico, your turn. Thank you.
Hi everyone. Yes, I'm Enrico. As Raul. Oh yes, let me share my screen. Yes, here we are. So yes, can you see it? So yes, I'm involved in a few open source projects because I really love open source, Yes, I've been dealing with Pravega, especially because of the connection with Bookkeeper. Yes, so yes, currently I'm the Bookkeeper project PMC chair. So I really love that project, and I really love the way Pravega is using it. So great. Today, I'm going to talk about generative AI because, you know, this year everybody is talking about generative AI. And I'm going to talk about a new open source project that I'm working on, that is LangStream.ai. And in the demo, in the end, I will show how to use Pravega inside LangStream.ai as a messaging bus to connect the agents. You will see later. So let's get started. Yeah, so this is the agenda. What is LangStream? The typical usages of LangStream, why you should use LangStream, a very high-level architecture of LangStream, and then an example. We have only 30 minutes, so I try to be brief and go straight to the demo. Okay, yes. So what is LangStream? Maybe if you are hearing about generative AI, there are a few libraries that allow you to interact with LLMs. So it's LLMs are large language models. So first of all, you have ChatGPT example. Yes, so there are models, there are systems that are able to speak human language. So you can interact with them using English, Spanish, Italian, whatever language you want. Yes. And now in 2023, this technology is usable by everyone. The costs are not that high. In this talk, I'm not spending much time about generative AI and why this is changing the world, but basically the big jump, the big change is that before generative AI, in order to do AI, you had to hire some data scientists, spend much money on training models, and not only a few companies could afford this kind of work. Now, with generative AI, you start with foundational models like OpenAI, Vertex, Google Vertex AI. There are a few. Yes, and then you can focus on your application and leverage the power of AI. So, but if you're using generative AI, there are a few libraries like LangChain, that is the most popular, Llama Index, there are others, but they are libraries. LangStream is a framework to develop the applications from development and to go to production. So it's also especially a runtime environment. It is also a runtime, a platform to integrate data. So basically in LangStream, you will see later, you integrate your data, you write pipelines that run over some messaging technology like Kafka, Pulsar, or now Pravega. Yes, so you can connect all your data with LangStream. And we are using, we based the LangStream on proven technologies like Kubernetes. I'm citing here Kafka Connect, but you can use many popular systems. So we didn't reinvent the wheel. So now generative AI is coming. People need to write real applications that can go to production. And so LangStream is trying to fill this gap. Another point about LangStream, there are of course already many integrations with the most popular services, the LLMs like OpenAI, Hugging Face, that is an open source repositories of open source models. You can use that. Google Vertex, Bedrock, and also many integrations to vector databases. I'll be talking about the vector database later, but the most famous are Pinecone, DataStax AstraDB, Milvus. You can use also Apache Solar. And there are other services like the embedding services. And also it allows you to deal with prompt templating, because with LLMs, basically you query the LLM writing a text in human language, natural language. So now the difficult part of programming this kind of stuff is about writing good prompts and interacting with the LLM in a way that it answers the right it provides the right answers without hallucinations. This is another topic that is very frequent in this kind of applications. And also it provides many tools and libraries to do natural language processing and also dealing with search results. Another thing is a development environment. And usually you can work with a no-code approach. So many applications can be implemented just by writing a couple of YAML manifests, like you do in Kubernetes. But if you need, you can code your business logic in Python, and you can use the most popular libraries like LangChain and LlamaIndex. Another really important thing is about dealing with unstructured data, because when you deal with language, usually you deal with texts, and texts are not structured data. So one of the most common use cases is to write an assistant, kind of a chatbot, that answers questions about a corpus of documents. So you need something that is able to parse the documents in different formats and then prepare them for the system in order to be actually usable by the LLM. Okay, let's go quick. And the other big point about LangStream is that it allows you to build event-driven architecture-based applications. So event-driven architectures, here we are in the Pravega community, so we know the importance of this kind of architecture. So with this kind of architecture, you can build scalable, asynchronous applications. You can easily implement micro-batching, and you can deal with many problems that usually face when you go in production and your system grows. And so if you start with a platform, a runtime that supports natively event-driven architectures, then you're good. You are prepared for. We usually say this title, LangStream helps you to solve the day 2 problems. Day 1 is you're happy, you are developing a new, fresh, new cool things with the LLM, with the artificial intelligence. Then day 2, you go to production and you have problems, scalability problems, dealing with failures, and having a streaming system under you allows you to solve many problems. Also, LangStream is based in Kubernetes, or on Kubernetes, so you can leverage many cool features of Kubernetes, from scalability to monitoring, security, dealing with the application life cycles. LangStream is open source, so is Apache 2 licensed. It's on LinkedIn, yes, on GitHub. Yes, you can connect with the community on Slack, and yes, you can find us there. It's easy. Some usages of LangStream. The most common use case is to build vectorization pipelines. So because in order to implement, let's talk about the most common use case, the chatbot. The chatbot is an assistant that is able to interact with humans. Yes. The LLM, like OpenAI, like ChatGPT, has an internal knowledge about something, but it doesn't know your private data. Yes, so the most common pattern in this kind of application is the RAG pattern, is retrieval augmented generation. So let me explain this, and then we will see in the demo how it works. So usually you have the LLM that is able to speak in language. You have some knowledge that it is usually in a vector database, or in your data. So you have your data somewhere, you have your systems, your databases, your anything. Yes. So when the user interacts with your application, the applications knows about the user and prepares a prompt, so a query to the LLM, and by combining the initial question from the user and some other additional information that cannot be available to the LLM. And usually this is performed by doing a vector search on the vector database and also retrieving other important information about the user. For instance, if you have an assistant that helps users to deal with your flights, flights. So maybe when the user is interacting with the bot, you read the story of the flights, maybe the next flight that the user has to take. And so you provide all this kind of information to the LLM, and the LLM is able to interact with the user. Yes, like a human. Yes, and that's great. But in order to do this, you have to feed the data inside the vector database. And this is the vectorization, vector embeddings pipeline. So you read the data from somewhere, you compute the embeddings, that is basically is a mathematical thing. So for one text, you compute a vector, something like 1,000 float numbers that represents the meaning of the text. And when you store the text on the database, you store the text next to the vector. When you look for relevant documents, you look for the vectors that are closest to the vector that represents the query of the user. So, and this way, this is kind of magic. It's all mathematical, but it works very well. And this way, you can find the most relevant text and provide them to the users. So building this pipeline to vectorize the tests is not an easy task, because maybe you have to deal with huge amount of data, you have to perform this computation that creates these vector embeddings, and then write to the database. So one big use, one common use of LangStream is to build the vectorization pipelines due to the intrinsic nature of streaming and scalability. Then chatbots with memory. So the chatbot usually, there is a question of chat. Okay, let's answer the question later. Okay, so just building chatbots with memory. The memory is that when you are talking with the chatbot, he is aware of the latest thing that you said, so you can refer to them using pronouns. The question and answers bot, just Euclidean distance with 10 case dimensions, yes, something like that. Yes, or for instance, other things, pipelines that read some text and then uses the LLM to create summaries, or other kind of chatbots that are really interesting. And yes, I don't have much time to explain now. Sorry. Then another theme. So why use LangStream or use generative AI with streaming and with Kubernetes? Because with Kubernetes you already have a platform to run your application and scale. You can run on the cloud easily. Yes. With LangStream, you can build really rapidly some prototypes, but sometimes you can go to production even with the first things, because also it is not only the runtime, but it comes with many built-in blocks that you can use out of the box, that implement the most common and useful recipes. Because now that generative AI is exploding, many people are saying many things because there are many theories. So we are picking the most stable patterns, the things that we know that work, and we make them available as no-code agents. So in a declarative way, you can say, I want an agent that is able to extract text from PDFs, or to call an LLM. So without requiring you to write code, try fancy theories. And then, yes, you can write Python, and you can deploy your application, the same application, without changing it in dev. So your laptop running on Docker, the same application can be deployed in production. We are using Kubernetes secrets to do all the management of the security credentials, and there is an advanced management for security, for multi-tenancy, and all the things that an enterprise usually requires for a runtime to be used. I haven't driven. Okay. At very high level, the architecture on LangStream on Kubernetes is that you deploy this operator. So there is a LangStream operator. There is a control plane. You deploy your application that basically is a bunch of, is a directory with YAML files, and if you want, with Python code. And then the control plane stores it in some code storage, for instance, in an S3 bucket or Azure Blob storage object. Yes, and then the operator creates stateful sets and all the other things that are needed to implement your application in Kubernetes. So there is a planner that, given your application, tries to find the best execution plan. So decide the number of which stateful set, how to connect the agents one to each other, and then it deploys it to Kubernetes. Oh, yes. And usually, in order to connect the agents, you have some messaging bus. So by default, we're using Kafka because it's the most popular. We are also supporting Pulsar because basically at DataStax we use Pulsar. But yes, it works also with Pravega. So we also implemented an experimental connector for Pravega, and we will see it at work. So the demo, in the demo, basically, I will give you the link to the source files. Don't try to read this. But the idea is that in the chatbot reads a question from the user. It calculates the embeddings vector, looks up the documentation in a vector database, and then builds a prompt. In this case, in the example, we're going to index the website with the documentation of LangStream. So we are using OpenAI. OpenAI is trained with data up to 2021, 2022. So LangStream was born only released on August 2023. So it is not possible that the LLMs knows about LangStream. So I'm going to ask questions about LangStream, and you will see that it is able to speak like a human. So this is the reference to GitHub, to the repository. The demo is like this. Start Pravega locally. You can install LangStream using Brew if you're on Mac. If you're on Linux or Windows, there is another way. I'm on Mac. Yes, and then run it. So there is a CLI, LangStream Docker run starts a Docker container with all the components of LangStream without the operator. Yes, and then runs the application. And also it starts a development UI. So it's a web interface that allows you to interact with the application. Let's see. Okay, yes. Starting it now from scratch. I hope that it's not interesting to see the flow of characters for sure, but now it is starting a Docker container with the LangStream and with the application with two pipelines. One is the web crawler pipeline that reads, basically it crawls the docs website for LangStream.ai. And the other pipeline is the chatbot. So as soon as the application is deployed on my laptop, it shouldn't take much time. It will start crawling, and you will see the development UI that pops up. We are using an embedded database. Okay, yes. So this is still the logs. The application, this is the two pipelines. One is the crawler and the other one is the chatbot. These basically are the things that you can query if you connect to the API. Then this is a very simple interface. Usually you write a real web application to interact with your chatbot. We also have samples with Node.js. Oh yes, so there is a problem. Why? Oh. This is the demo god.
Yeah, that's called the demo effect. So
Yes.
maybe it worked like 20 times before, but in the
Yes. Because I run it. I am running it every day. So yes. This time the difference is that we are using Pravega. So yes, it's starting.
Is the LLM running locally or
No.
on OpenAI?
No, it's OpenAI. So I'm using OpenAI.
Okay.
So
Because I read on M1 and M2, they're able to run some LLMs on Macs.
Yes, but usually for a demo,
Yep.
It's better to use OpenAI. Also because yes, running an LLM has some costs. So I don't know why it's not working. It was cool. Oh yes.
Someone says that OpenAI is down right now.
Oh yes. I had problems. Maybe that's it. I want, and I switched to Azure. Here while I was talking with Raul before the meeting, because it was down. So yes, there is some other problem. Yes, unfortunately. Oh no, this is a problem. Oh, this with Pravega. Oh, by the way, I can show you. We are running out of time. I'm sorry, but yes, there is the demo, and I show you give you the.
Sure.
Yes, so this is basically the code to run the demo. If you want to try it locally, it should work out of the box. Let me share it on the Zoom chat. So it's pretty straightforward. Yes, so let me wrap up a little bit what I said. So yes, LangStream was born to fill this gap from playing with Python libraries and going in production. You can write Python, and this is good because you can use LangChain. That is great. But also you can deal with the problems of going in production. No code is a good approach. You can integrate with all the popular LLMs, and also if you use LangChain, you have a very wide ecosystem. You deploy your application in Kubernetes natively. Of course, we have Grafana dashboard and all the other things. And yes, this is really effective. Yes, so we're seeing people that yes, enjoy this way of working with generative AI. So thank you. This is the GitHub repository. If you have 1 minute, please start it. Yes, you can connect with me on Slack, on LinkedIn. You can find me, or especially in the Pravega Slack, because I'm there.
Thank you very much, Enrico. That was a great presentation, and it's interesting to see how you have connected Pravega as an eventing or streaming substrate for LangStream. That's really cool. I mean, no worries. That's the demo effect. That's what happens sometimes in this situation. And thank you for, if you can share this, the reproduction of the demo also in the in the Pravega channel. I think that people will be able to reproduce that, and it will be there in the Slack rather than in the Zoom chat.
Yeah.
Cool. So maybe we can switch to our second speaker. He's Olivier Noguer, and he's an engineer at Ledger.com. He's an expert on akka streams, and contributed heavily to the ZIO library as well, even the connector for Pravega. And yeah, so I think that he's going to speak a little bit about some work that he has been doing with transactions and how to do some kind of distributed management of Pravega transactions. So without further ado, it's over to you, Olivier.
Okay. Can you hear me and see my screen?
Yes, we can. It works.
I can just move this bar. I'm not used with Zoom anymore. Up, sorry. Up. You should see the presentation.
Yes.
Okay.
Yes,
So hello. So I'm Olivier. I'm working at Ledger in crypto space. It's Onugi on Twitter if you want to talk to me. I will talk to you of my little pet project, which is to play with transaction Pravega and to use them transaction to implement distributed transaction within a microservice. First of all, it's a dream stack I work with. It's the Scala, ZIO. I will quickly present to be clear, and of course Pravega. So Scala, it's I don't know if people know Scala. It's a multi-paradigm language and targeting JVM, Scala, and Scala native. It's quite old now, more than 20 years. It's object-oriented and functional, and very strong type, and with a generic programming very advanced. We'll see. So a little bit of syntax because I will show you a little bit of code and a small demo. Scala is more or less like Java. Threads are interfaces. Okay. Generics are with square bracket and not angle bracket, and that's it. Case class are just like records in Java 21, I guess, or continue data class. You can see the syntax is quite compact, so that's why I like this language, to be honest. A method. So the type and the name of the variable are inversed compared to Java. So that's it. And in the second line, you see lambda, like a lambda Java. It's very compact. Okay, and a method to this one. And you should notice that this method there has two lists of parameters. Okay, so not very common. It don't exist in Java. And what it means? It means that there is you receive sometimes you can call it with two lists of parameters, and it will have many importance. In fact. This is a high order function map. Okay, that's a function that takes a function. And you can see it's it's as compact as in JavaScript. It's very cool. Simple example of serializer. It's my serializer for Pravega interface. You can say how we can use this serializer. There is and we have a method serialize that is able to serialize a generic object, provided the fact that there is a serializer available. And what is very useful in Scala is when you call this just serialize with an object. I don't give the serializer. Okay, the serializer is provided somewhere. It may be even generated by macro. So it's very useful to use. ZIO. ZIO, it's an open source library, of course, done to write asynchronous and highly concurrent programs. It's very composable, as you will see. Resource safe, it's quite important. Okay, when I'm allocating critical resources like connection, I'm ensure that they will be released as soon as possible and performant, because it's already using light threads like Loom, Project Loom, you know, in Java. In Scala ecosystem, we already have this for a very long time. So ZIO, it's what it's called, it's a functional effect system, and it's allowed to program in sense of effects. What is an effect? It's a computation that can fail sometimes, and you can success with a result. Everything is presented as type. Okay, this is, for example, in ZIO, an effect that cannot fail. For example, if I an effect that is just doing computation with a known value, multiplication, it won't fail except if the GVM is failing. Of course. This other effect has two types: one error and one success. That means that this effect can fail. It may happen. And this last effect, sorry, it's not. This is the ZIO effect that has three generic types: a resource, an error, and a result. So it means that it can succeed, of course, can fail, but also it may need some environment to execute. For example, a connection to database, a pool, HTTP client, something like this. It's kind of ingestion mechanism in the language, in fact. Sorry. Now, you see, I'm talking of some smaller object like IO. It's just a context around a value. In Java, you are used with future, I guess, or option, which are more or less same kind of object, meaning that just a context around a value. I will just show you how we manipulate this in Scala, because this is a pattern you will see everywhere in Scala. Let's imagine we have three options. Okay, option containing value 1, another with 2 and 3. And what you want to make the sum of this all of the options. The naive and bad approach is to use a get to get the value from the option and doing the computation. You don't have to do this. It's a fault. Because of course, if one of the option is empty, we have a runtime error. And as a Scala developer, you will be very shameful to have a runtime error. It's a copy error are common, runtime are bad. So in general, another approach is to go through the option, doing I'll say traversing the option, and I don't know what traversing. Just doing FlatMap. I think FlatMap is there in Java also now to say this, to map to go into the option and make some computation. I don't know if everybody knows what FlatMap. I didn't know if it's I hope it's common for you. So that's the way to do. You go in the option, go inside, and apply a lambda in what contains the option. Okay, it's just FlatMap. It's so common in Scala. I'm sorry. And things like this. When you do this, okay, very nice. You're safe. Your computation will always success. If there is an option that is known, you just have no known as a result. No more exception or null pointer error or something like this. It's safe, but it's very ugly. Okay, because it's implicated. You have some deep nesting of function. It's awful. In Scala, there is this statement which is called a for comprehension. It's specific to Scala. That is just the same thing like that. Okay, it's the same. It's just a syntactic sugar, in fact, but very very common. I hope you find this more clear than this one. And sorry, real world example. Imagine I have a location, just a case class, a record, a pojo, I would say in Java, that has two values, string value, and a bunch of methods. One method that from a hint retrieve a user from some HTTP server. Another method that retrieve locally from database a user, an address from a user, and a location from an address. I want to compose all this action IO to make a bigger one. This with using format that would be this ugly syntax. It works, not easy to read and not to write. With for comprehension, that's just there. I hope you find this quite clear. Okay, it's just call this, get the result, call this, the user is forwarded like this, and the whole result is an ZIO that would combine all these actions and will be given to an interpreter to perform the execution. Just an example of ZIO, very simple, just a program that just asks you your name and print you hello, who you are. So it's a line 3. You can see it's a program that don't need anything, may run an exception if there is if the IO, if the string, if the std in or std out are broken, and return a string. You give it to an interpreter that will for you run any thread. If you want a new thread, catch the errors, run things in parallel if you are using a parallel combinator, things like this. And of course, the type are optional in Scala because all is infer. So just for readability. Pravega, I won't go too fast. This is the suggestion of Copilot. Okay, it's durable, scalable, fast, and many other properties. Everybody hopefully knows a little bit about the Java API of Pravega. This is a small sample example. Let's imagine a small client that want to read events. I do Java print. I acquire a reader from the Java API. This is a Java example I will show you after the Scala one, of course. I iterate through the stream, through the stream via the reader, and I print a no more event. The output is expected like this, of course. And this is equivalent in Scala. Okay, the statement of login. This is equivalent of acquiring a reader. This reader is there. This reader will be instantiated really at that moment and piped through a sink to consume the reader and the output. As you can see, there is a for comprehension there. In Scala, you will see every time this kind of in Scala using functional effect, every time this kind of construction with cats or ZIO. And it's okay. So what I wanted to achieve, is it big enough, the diagram? Yes.
We can read it.
You can read it. Okay. So I have 3 services: a shop service, stock service, and payment service. So each service has his own queue on stream of Pravega, and I have a last stream that will receive the completed or not transaction. Okay. Now the idea is that I want this service to open a transaction on an store, writing some events, calling another service through the queuing. This other service can write events and so on, and a third service. And at some moment, the transaction is committed if everything goes well, of course. And at this moment, you can every other services can apply the event, aggregate their state, and so it's implement a distributed transaction, quite seamless. And you see the code is very small, very easy in fact. In Scala. So do I have time? Yes, I can have 10 minutes less.
Yeah. You still have
okay.
We still have 13 minutes for.
Okay, perfect. So this is how we write a connector to Pravega in Scala. The important part, this part is where we acquire a reader from the Java API. There I will begin the transaction. Of course, this reader it's acquired, it must be released. Okay, because it will leak a connection if I didn't release it. Same thing for the transaction. this again another for comprehension. Okay, we have two IO that are combined with a sync. It will interpret all the IO for every event that will arrive to the stream. Just a streaming API. It's quite simple, but I don't have time to explain how it works. And this line is just the line that provides the finalizer to the stream. Okay, when the stream will exit, this line provides a trigger, let's say a trigger to finalize what should be finalized, like transaction and connection to Pravega. So this little, how do I acquire a reader to Pravega? Again, you see, it's read code in Scala and ZIO. Everything is one liner, one liner. It's very easy to read. In fact, so to acquire a reader of Pravega, this is my function. You see, it's an effect that has three parameters. Let's see the first one, the easiest one to understand, throwable. It may fail with an exception. It may. It produces a reader of object of type A. And there is also this element. This effect to be executed needs a scope. And what is the scope? It's this due to this combinator. This combinator is callable in this context because this line is a Java API, okay? More or less, I think. This line produces a reader, an event writer, sorry. This event writer is autoclosable, as you may know. And because it is autoclosable, I can register the call to the closable, okay? That's the equivalent of storage with resource in Scala, in Java, sorry, but doing with Scala, with ZIO. And doing this call, brings a dependency to a scope. Now it will register the finalizer, but it needs a scope to register this finalizer. That's what the writer. When I open a transaction with Pravega, the same kind of story. I have a REO. REO is a type alias to remove the swivel that will produce a transaction, and will also need a scope. This time there is two callbacks. One callback to initiate the transaction, and one callback to close the transaction. When the scope will be closed, meaning when the stream will be ended, because no more events, or because it is closed, it may fade. If it fades, I will just abort the transaction. If it succeeds, I will just commit the transaction. Okay, that's as simple as that. Of course, you have to know a little bit of syntax. So I will show them more. Pravega. I will start Pravega also to create the resources and play with the transaction. So to start Pravega from fresh. Starting. I don't use Docker, as you can see. But, I should previous demonstration use Docker on Mac. You don't have any issue with that? With M1, I had some issue. So Pravega is started. I need to this bar is never at the good place. I need to create some resources. It's is it big enough? Is it readable? Is the code readable? Or should I zoom a little bit? No.
Yeah, I can read it at least.
I can read. Okay.
I can, yeah.
So this is a main method to, for example, to create some resources on Pravega. Okay, it's a program that needs a Pravega manager because of course it had some it came from nowhere. And on this Pravega manager, I will create a scope I pushed in some log, create stream for the every services and the shared transaction. As you can see, this means that to be runnable, this IO must have something that will provide a Pravega stream manager. This is done by a mechanism at compile time of injection that is there in this part. This is my IO that's need, and I provided a stream manager with this call. And what is quite funny is that this part is done at compile time. Okay, if you want to see what it's doing, there is some macro that can show you how a Pravega stream manager is built at compile time. It uses using a scope, it's ZIO stuff, and also Pravega configuration, something another layer that can provide this configuration. And this can be as deep as you want, as you have memory. That's it. So I can cross this. It creates, of course, all the topic I need. Of course, if I call again, it won't be created because they already exist. Now, I can start a small HTTP API. Shop service, it's a first service that would, and I will open the UI. This is a small simple example. Okay, I just have I choose a book. I push the book to the API. It's arriving on the web API. The web API push this to the shop service. I didn't start the other services to have the time to show you the transition because it's too fast. If I start the stock service, it receives the stock request. It pushes it to the payment service. The payment service reply to the shop, and the shop commits a transaction, and everybody is happy. So as you can see, it's quite easy. Now I can start from another book, another book. I don't know. Everything should arrive, and the loop is. Voilà. I made some pause of 2 seconds every time to have time to see the stuff, and to show you how it is implemented for one service. This is the code for one service. Okay. With comment, and that is all I have to do. Of course, there is some helper library. It's not from raw API, but it's very easy. It's again a program, you can see, that have some dependency, a scope, because there is some stuff to clean up at the end of at some time. A reader group manager and Pravega stream, because I need to instantiate reader groups and stream, of course. A small log. This is the loop to listen to transaction to see when transaction is committed. This is the stream of the service of the shop service that waiting for event to be received and handled. This is a queue to send messages to other services via Pravega, and this is just a loop. Okay, where the service listens to his request. When I receive a book request, I made some log, I made some temporization. I start a transaction, and I offer a request, a message to the next service. This is and on the return, of course. The idea, what is funny is this: when I start the transaction, this code, you can see, always this is the ubiquitous structure in Scala, in functional programming, in functional effect system. I have a promise to retrieve the ID of the transaction. I push, I start a sync with a transaction mode that will complete the ID of the transaction when the transaction would begin. Because transactions are quite lazy. Until nobody tried to write, it won't be available. So I need a promise to do this. I wait this promise, and I return the ID. Note that this await is not blocking, okay? Because it's not native thread, okay? It's a like Loom. It's a applicative thread. So we are allowed to lock. It's not a native. It will be shamey. And doing this, I received the ID of the transaction, and as you can see, I just forward the ID to the next service, and then the next service, which is payment, or I don't know, payment or stock service. It's the same structure. When you receive the request, I have transaction ID. It's a different process. Okay, I can retrieve this transaction right in the same transaction. Sorry, and calling another service and things like this, and we are done. But fine, quite funny. And what should I say? Should I add to this? I don't know. What is not implemented because it was just a try this last month. It's only a choreography. Okay, so meaning every services call the next service. It's quite easy, but to perform more complex workflow, it will be quite tedious. So we need some kind of orchestration. Donc I say some tools to do this, but I didn't test it. I don't know yet what I could do. Also, I don't have yet a clean solution to be notified when a transaction is cancelled. Because yeah, it's okay when transaction is committed, every people listening are notified. But when it's cancelled, there is no mechanism, as far as I know, in Pravega to listen to cancel transaction. I can do this on my side when I cancel when I abort the transaction, I can push a message in the topic in the stream. But that's not. I will do it because I think it's quite funny. Conclusion: this is a completed conclusion, so I won't comment too much. But it was quite funny. I hope you enjoyed, and some resources if you want to go more deep in the subject. ZIO, ZIO, it's a effect system. Pravega, you know, of course. And this is my connector to Pravega. Thank you. If you have a question, I will be happy to try to answer.
Cool. Thank you very much, Olivier. It was impressive. You know how you integrated Pravega in your framework with ZIO, and all this mastering Scala that you gave us. It was great. I mean, we are at the top of the hour, so I would suggest that if you have you want to follow up with any of the speakers, let's do that in the Pravega Slack, including the demo from Enrico, or anything related to the demo of Olivier. We can continue the conversation in a Slack. I think that I would say that that's it for today. We will try to keep doing Pravega community meetings. I think that in a bi-monthly approach, I think that that's a good enough cadence to provide good content to the community. And that's it. So thank you very much to our speakers, to Enrico and Olivier, and to all the attendees. Thank you very much, and see you.
Thank you.
Bye. Thank you very much. Bye.